This video is on writing formulas for ionic compounds. So you should already know how to combine ions to write a formula with a cation and an anion. So now we're going to take it one step further, one step basically previous, and given a name, now determine the ions and then determine how to combine them to write the formula. So ions need to be first determined from the name if you're going to write the compound. So a couple things to help you do that. The cation name tells you the cation. That will be the first name in your name given for your compound. And the cation name does not change, meaning if it's calcium, it'll just say calcium, no ending change, nothing. Transition metals, you'll know their charge because they will have a Roman numeral there. And they're always positive. Metals are positive, right? They have low ionization energies to lose their electrons, so they become positive. So you'll see something like iron 3, for instance. So that means that your cation is Fe plus 3. Anions will be the second part of your name. And if the name ends in IDE, like chloride or fluoride or oxide, that means it's just that one element. So this would be like chloride. And that would be just chlorine, so Cl with a -1 charge. If the name doesn't end in IDE, it's a polyatomic ion. So like sulfate, SO4 - 2, and so on. There's 2 exceptions. 2 polyatomic ions actually end in "ide". So hydroxide and cyanide, you just need to know those names. You need to know the polyatomic ions. So just be careful with the "ide". It's always going to be an element unless it's hydroxide and cyanide. So let's do some examples. So let's start with a name, one you all probably know, sodium chloride. Make sure you're writing all of these examples down, even the ones I just wrote up there in the notes. So sodium chloride, so think of this, right, as a positive and a negative half. Here's your cation half, and here's your anion half. Remember, cation goes first. So we have to figure out what our ions are. So sodium is, symbol is Na. You look it up on the periodic table, its charge is +1. Chloride, so it ends in "ide, and I use that as my example of above, means it's just chlorine, and its charge is -1. So when you combine these, you need one of each, because their charges already balance out, so your formula would be NaCl. Okay, let's do another one. Excuse me. Let's do potassium chlorate. Okay. So our positive in this case is potassium. Metal's going to be your cation. So we've got K, and its charge is +1. Chlorate, so it doesn't end in "ide". So it's not chlorine. Chlorate is your polyatomic ion. That is ClO3 -1. So again, your charges balance out like the last time. So your formula is going to be KClO3. Very different from KCl, which would be potassium chloride. So there are very small differences, but they do matter. All right, so another one. Let's do aluminum hydroxide. So your cation here, aluminum, is a +3 charge. Hydroxides, remember I said you got to be careful if it's hydroxide or cyanide, it is a polyatomic ion. Hydroxide is OH -1. So now you're going to need more than one of some of these to balance out their charges, make them add up to 0. So if you have 3 aluminums, you're going to need to multiply your your hydroxide by 3. Taking this 3 over here, right, and the 1 over here. So you're going to get 3 hydroxides, AlOH. And what I'll see a lot of students do is they'll write a 3 here. If you write this, this means you have 3 hydrogens. But you have 3 of this whole group, polyatomic ions, stay together, 3 hydroxides. To show that, you need to have the parentheses there. You have 3 of everything in the parentheses. The way we read formulas like this are with parentheses. It was we say taken however many times, however many your number is outside of the parentheses. So this would be ALOH taken 3 times. So let's do a few more. So let's do aluminum, or sorry, we just did aluminum. Iron. Iron 3. So Roman numerals, 3 lines, 3 I's is 3. Ask your teacher if you're unsure about which Roman numerals mean which number. So iron 3 sulfate. Okay, so our cation is Fe plus 3. So remember, transition metals are always positive. The Roman numeral tells you positive how many. Sulfate, SO4 minus 2. It's one of your polyatomic ions. So in this case, we're going to have to multiply them both, right? You need 3 sulfates and 2 irons. So Fe2 SO4. Remember, polyatomic ions, if you have more than one of them, you need parentheses. Taken 3 times. If your polyatomic ions, remember, you don't need more than one, no parentheses are needed. And you really should not be writing them. All right. A couple more. Ammonium oxide. Alright, so in this case, we have a polyatomic ion as a cation. This is the only one we're learning about. So ammonium is NH4 with a +1 charge. Every other cation that we're going to deal with is going to be a metal. Oxide means it's just oxygen, so it's O minus 2. So we need 2 ammoniums. Polyatomic ion, we have more than one, so we need parentheses. NH4 taken twice. O, we only need 1 O. And one more, we've got calcium chromates. Okay, why don't you pause the video and try this one on your own before I go over it. So the cation for this would be Ca plus 2. Chromate, so it's a polyatomic ion, CrO4 minus 2. Oops. So when you combine them, you only need 1 of each. Be careful. You don't want 2 of these and 2 of these because they're both 2. You can reduce it. So our formula would be CaCrO4. And we only have 1 polyatomic ion, so we do not write parentheses around it. That is how you write a formula given a name for an ionic compound.